Welcome everyone to another episode of West Explains Best. We're going to be doing a Khan Academy tutorial today, add fractions with common denominators. Now, anytime you add or subtract fractions, you need common denominators, and these are just all going to have the same one for you, so you understand how to get the hang of it. Okay, so our first task is 4 over 6 plus 8 over 6. Let's put this into perspective for you. I think food and pizza, like chocolate bars, is the easiest way to understand fractions. So I am going to relate this to chocolate bars. And I guess I should have used black to represent chocolate, but close enough. So I need a chocolate bar with 6 pieces. So 1, 2, 3, 4, 5, and I need another one. Okay, and we're going to make another one with 6 pieces. Okay. So there's another one, and actually I'm going to need a third one. I'm going to show you why in a second. 2, 3, 4, 5, 6. Okay, so the first fraction, we'll do this one in orange, is 4 over 6. What does that mean? Well, we have 1, 2, 3, 4 out of the 6 total bars. So you know how you can like break up chocolate into different chunks? This is especially true for like Hershey's or some other, gourmet chocolate. Well, that represents the number that we have. So if I wanted 4/6 of the chocolate bar, that's how much I would need to eat. This portion right here, okay? That's 4/6. Now, what if I had 8 over 6? Well, what does that mean? Well, usually the bottom number is bigger than the top number with fractions. So what does it mean when it's bigger than 6? Well, that means we have 1, 2, 3, 4, 5, 6. One complete bar and a little bit extra. That's more than 1. Okay, so that's more than 1. So you have more than the original amount. So that's what that means. So what are we going to do? We're going to add these two things, these two fractions together. Since we had 4 here, 4 squares, and we're eating an additional 8, how many total squares are we going to be eating? Well, we are eating a total of 4 plus 8. We're eating a total of 12. Now, this is where the common denominator is essential. Notice how they're all the same size unit, okay? These units are all the same size. It doesn't work like this if they're not. You only can compare like chocolates when you're trying to add them up. Imagine if you had like a chocolate bar like this, and you said that this, like if we wanted to say that that's 1/2, no, sorry. We couldn't call it 1/2. Well, it is 1/2, but we couldn't call it 1 out of 6 because clearly this piece is way bigger than one of these 6 pieces. So we only can compare 6 with 6. We couldn't call it that. We can only compare halves with halves, okay, because they need to be the same size so it gives an accurate representation. So in this case, we have 12 over 6 is going to be our answer. What's the rule? The rule is add or subtract the top, and you leave the base. Leave the common base or common denominator. I like calling it the base because denominator is just a mouthful to say. So we have 12 over 6. I'm not sure if it's going to be asking us to put it in simplified form because you can simplify this to 2. 12 over 6 is 2. Let's see what it says. Okay, it likes it. There we go. This is exactly what I'm talking about. Here we have 1/2 plus 1/2. Okay, so here we have 1/2. Here we have another half. Okay, there's the half. You get the idea. We can compare these because they're the same thing. We couldn't say that if this was this divided into this many, I think that's 5. We couldn't say that that's the same thing. We couldn't say that is 1/2. And combine it with the other ones because that's clearly not 1/2, that's 1/5. So we can't just say, oh, that's 1/2 plus 1/5. It doesn't work like that because they're not the same unit. It should confuse you a little bit because combining these without converting them into the same thing doesn't make sense. And we'll talk about that in a different episode. So here we have 2 over 2 because we have 1/2. We're going to add the top. 1 plus 1 is 2. And then keep the base the same, 2. Next question. Okay, which of the following is true? Is 3 over 4 plus 1 over 4 equal to 4 over 8? Okay, is 3 over 4 plus 2 over 4 equal to 6 over 4, or is 3 over 4 plus 2 over 4 equal to 5 over 4? Well, here's a problem. This one, they added the base. You cannot do that. You cannot add the base. They added the top, which is fine, but they added the base, which is not, so they can't be that one. This one, they kept the base the same, which is good, but then they just added improperly there, so it's C because 3 over 2 equals 5, and they kept the base the same. So we're going to put C as our answer. We're going to see if the next two have any surprises. It looks not. We're going to add the tops here together. We get 14. And we're going to keep the base the same, which is 12. This episode is not talking about reducing, so we don't need to worry about that just yet. Here, same thing. We have add the tops. We get 4. The bases stay the same. We get 4. Keep that the same. Now, if you're into reducing, we could call that 1. Which of the following equations is true? There we see that this one, they add the bases together. That's no good. They kept the base the same, but then they added wrong, so it looks like it's the bottom one again. And we're going to call this our last one just because, no, we might as well finish it up. So the last one, ooh, nice. We have a little tough problem here. Tougher than the other ones. So the base is going to stay the same as 100. We can go ahead and put that in there. And then we add 85 plus 30. That gives us 115. All right, show the summary, and this is what you are going to see, which is a great result. Hope to see you next time. Thanks for watching.